3.1 Polynomials. So a polynomial in X is an expression that consists of terms that have non-negative integer powers of X only. So in the yellow box here, we've got the long-winded way of explaining all of that, but let's just take a look at some examples and it'll become really clear for us. Here we have what we call a quartic. The degree of this polynomial is 4. So you can see the highest power of X here is a 4, so therefore it's degree 4. Anything of degree 4 we call a quartic. The next one we're considering here is a cubic. So the degree here is 3. The highest power of X we have is a 3. And here we have a quadratic, degree 2, a linear, which is degree 1, and a constant, which is a degree 0. So we look at the X and we think of the highest power, and that's what we call the degree. So this 23 can be written as 23 times X to the power of 0. And of course, anything to the power of 0 is 1, so it just becomes 23, i.e. that constant. With all of these polynomials, the powers of X need to be a positive whole number. That's a integer, as we refer to it. So it can't be to the power of a half, and it can't be a negative power. A binomial is any kind of expression that has two terms. So as an example, 2x plus 3, I have two terms. And in this case, we refer to it as being a linear binomial. X squared plus 3x minus 10 is an example of a quadratic trinomial. So the highest power of X is 2, so therefore quadratic, and there are 3 terms to it. This expression here is not a polynomial because this can be rewritten as being 3 multiplied by x to the power of negative 3 plus 2x. So here we have x as a negative power. In the same way, the square root of x plus 3 is also not a polynomial because that can be rewritten as x to the power of half plus 3. So we've got x to the power of a fraction here, not a whole number. So therefore, it is not an example of a polynomial. Yet this one's okay. We can rewrite this as being 1/7 times x cubed. So the coefficient of the x can be a fraction, that's fine. But this is 1/7 of x to the power of 3, so that's a positive number there and a whole number. And then we've got the constant, which is the square root. So we can have the constant involving the square root symbol, that's fine, just as long as it's not the x parts. Polynomial notation, p of x means that the polynomial is written in terms of x. P of 2 is the evaluation of p of x when x is equal to 2. So it's just a substitution of x equaling 2 into the polynomial. We can evaluate polynomials. So in this example here for problem 1, we've got p of x is equal to x squared plus 3x take away 8. So to evaluate what p of 2 is, I write down p of x. And now I substitute wherever we have an x, I put in a 2. And then work that out, and we can see that p of 2 is equal to 2. P of 1 for b. Here's my p of x. So p of 1, just a substitution of 1 for x, and we can see that p of 1 is equal to negative 4. For c, p of negative 5. Again, I take the p of x and I just substitute x equaling negative 5 to get 2. This might look a little bit different for d. I'm trying to evaluate what p of a is. So p of x is equal to x squared plus 3x take away 8. So wherever we have an x, I substitute it with a, and you can see p of a just becomes a squared plus 3a take away 8. We can also use our CAS. So here we've got an example. I've got p of x defined and I need to evaluate this. So my first job is to define p of x and then I just substitute. So I evaluate what p of negative 2 is. And we can see this in this example here. So I've got quite a complicated polynomial. P of x equals 9x to the power of 5 plus 5x to the power of 4 plus 4x cubed plus 10 squared. And we need to evaluate what p of 0 is, p of 2, p of negative 3. Whenever we write this, you just simply state what p of x is. And then we've got p of 0, write down what it's equal to, p of 2, what it's equal to, p of negative 3, what it's equal to. Of course, what we did was used our CAS. So we defined the function, and then did the evaluation. So looking at that p of x function, menu, add my calculator, and now menu, actions define. We put in p of x equaling 9x to the power of 5 plus 5. And it's a good habit to put times in, so it's always the best thing to do. 5x to the power of 4 plus 4 times x to the power of 3 plus my 10 to the power of 2. Now we know that that's 100, but that's what we've got. Now to evaluate, so firstly for a, p of 0. Notice that the function's defined, so it's in bold now. P of 2, 500. And then finally, p of negative 3 should equal negative 1790. And there it is, done. Easy. 3. We've got the polynomial p of x is equal to x squared plus 9x plus c. We know that when we substitute 2 into the polynomial, the result's 25. We have to work out what c is, the unknown constant in the end. So I state by writing down the original polynomial. I know that when I substitute 2 into it, the result's 25, so I write p of 2 equals 25, and that's equal to 2 squared plus 9 lots of 2 plus c. Working down through the basic algebra, you can see we can arrive to the idea that c is equal to 3. On our CAS menu, actions define, and I'm going to define p of x, and that's equal to x to the power of 2 plus 9 times x plus the unknown constant c. I'm now going to solve, so menu algebra solve, and I want p of 2 to equal 25. I'm solving for c. And you can see we get c equaling 3. That's problem 3 done. Problem 4. We've got p of x equaling x squared plus bx plus c. We know that when we substitute 1 into the polynomial, the result is 2. When we substitute negative 1 into it, we get 6. We need to work out what b and c are. Here's what I do by hand. So I'm going to start with the substitution of p of 1. So p of 1 is equal to 2, which must equal 1 squared plus b times 1 plus c. I now have 2 equaling 1 plus b plus c, and you can see it becomes clear that 1 is equal to b plus c. Taking away b from both sides, I get 1 minus b equaling c. I'm now going to use the second bit of information. So p of negative 1 is equivalent to 6, which must equal negative 1 squared plus b times negative 1 plus c. Negative 1 squared becomes positive 1. And now, instead of writing it c, I'm going to write what c is equal to. I know from above that c is equal to 1 minus b. So I just replace the c with this 1 minus b shown in brackets. And I'll get 6 equaling 2 minus 2b. Subtract 2 from both sides to get 4 equaling negative 2b. And now divide both sides by negative 2 to get negative 2 equaling b. What's c equal to? I go back to this rule. So c is equal to 1 minus b. I now substitute negative 2 for b to get c equaling 1. So a little bit of work in that. Obviously I can use my CAS calculator as well, so I can define p of x and then solve. So menu, algebra, menu, actions, define. So I'm going to redefine p of x. So p of x is going to be equal to x squared And this is why it's so important to use the multiplication symbol. So it's going to be plus the unknown b times x, where x is the variable, plus the unknown constant c. We've got to put multiplication in there because otherwise the CAS will think it's the variable bx rather than the unknown coefficient b multiplied by the variable x. So I've defined it. Now let's do the solve. So menu, algebra, solve. And I want two functions or two equations in here. So I'm going to put in my two equations. So I'll select that. And the first one is that p of 1 is equivalent to 2. And the second one is that p of negative 1 is equal to 6. I'm solving for A and I'm solving for B. So I've just defined the function, I've put in my 2 bits of information, and I'm solving for the unknown A and B. Now I've incorrectly put in A and B here, but of course what it should be is B and C. So it's good just to double check everything. And here's my question. Hit enter. And you can see that B is equal to negative 2, C is equal to 3. And now this makes sense. You can see the mistake that has been made here. 1 take away negative 2 is in fact positive 3. It's not 1. So what I've written here in the notes is incorrect. C should be 3. And there's really good advantage there of using the CAS whenever possible. So it's quite easy to make small arithmetic mistakes when you're doing things by hand. Clearly that should be a 3. Okay, problem 5. P of x is equal to this quartic and Q of x is equal to this cubic. I need to evaluate what P of x plus Q of x is, and then also Q of x take P of x. What you'll see here is that the CAS calculator can do this really quickly for us, but this is how we'll do it by hand. So I want P of x plus Q of x, so I begin by writing down P of x, and I'm adding to it Q of x, which is that cubic here. The highest power that I have is to the power of 4, so I've got 3 lots of x to the power of 4. I'm now going to look for a cubic, and I've got 1 lot of cubic, so it's 3 lots of x cubed altogether, and that should be plus 3x to the power of 3, so you can just change that in your notes there, so it's to the power of 3. I'm now going to consider the x squared, so I've got minus 2x squared plus minus x squared to give me negative 3x squared. I'm now going to look for the x's, so I can only see one term involving the x, so I've got 4x. I'm now going to consider the constant, so it's negative 1 plus 5 to give me plus 4. We're also asked to state its degree, so that's the highest power of this polynomial, which is 4. For part B, I'm looking at Q of x take P of x, so I begin by writing Q of x. I'm subtracting from it P of x, so notice that I put a minus sign and then put this in brackets. And the reason for that is so I don't mess up the powers. I'm now going to get rid of the brackets, so everything that's inside it, which is P of x, is going to be multiplied by negative 1. So I get negative 3x to the power of 4 plus 2x squared minus 4x plus 1. Again, I go through looking at the highest power. So the highest power is x to the power of 4, and I've got negative 3 lots of that. Then my cubics, I end up with 3x cubed. My squares, I've got negative x squared plus 2x squared to give me positive x squared. And my constants, I've got 5 plus 1 to give me 6. On my CAS, here's the approach. So menu, actions define. And I'm going to have P of x equaling 3x to the power of 4 plus, minus 2x to the power of 2 plus 4x minus 1. There's P of x defined. Define Q of x. So Q of x is going to equal 3x to the power of 3 minus x squared plus 5. Now for a, I need to evaluate what p of x plus q of x is. So I'm going to go p of x plus q of x. There it is. And for b, I need to evaluate what q of x taking away p of x is. And there's that. So you can see that the CAS, after you define them, is really quick to perform all those different operations.